The AIM-9 Sidewinder, an enduring symbol of American military prowess, stands as a testament to the longevity and adaptability of military technology. This missile has been a technological marvel for over 6 decades, reigning supreme in aerial warfare. The Sidewinder's impact is not limited to the U.S. It's the most widely used air-to-air missile in the Western world, with over 110,000 units produced for the U.S. and over 30 of its allies. Its introduction during the Vietnam War marked a turning point, and since then, the AIM-9 has been credited with over 270 aircraft shootdowns across numerous global theaters. But when this iconic missile began to show its age, Raytheon stepped in, securing a contract to upgrade its already lethal heat-seeking capabilities, enhancing lock-on target acquisition and improving effectiveness at ranges where traditional systems falter. The AIM-9 Sidewinder will continue transforming aerial combat for decades to come, ensuring Allied victories in the skies across the globe. The AIM-9 Sidewinder is a legendary supersonic missile renowned for its heat-seeking capabilities and explosive impact. Carried by fighter aircraft, it boasts a high-explosive warhead guided by an infrared heat-seeking system, making it a lethal weapon in aerial combat. Initially developed by the United States Navy for fleet air defense, the Sidewinder was soon adapted by the U.S. Air Force for use by fighter jets. Its early iterations played a crucial role in the Vietnam War, showcasing its effectiveness and solidifying its place in military history. Yet, it was not like this during the humble beginnings of the iconic missile. The AIM-9 Sidewinder was born from a secret experiment conducted in 1945 when World War II ended. A group of engineers at the in Yorkton, California-based Naval Ordnance Test Station were researching lead sulfide proximity fuses that were extremely sensitive to infrared radiation. Then, lead physicist William B. McLean concluded that there was potential for a new kind of missile guidance system. McLean thought that if a proximity fuse could use infrared signatures to initiate detonation, it could also track an infrared signature. In other words, the missile would change its course during flight to keep the target's heat signature reflected onto a sensitive photocell, allowing the rocket to actively seek heat. The idea was innovative, but the problem was that McLean's hobby shop was not in charge of designing weapons. However, that did not stop the team from going forward and experimenting. McLean, unfazed by his peers' skepticism, led his team in the development of an innovative infrared system to guide standard 5-inch air-to-ground rockets. Getting it right was tricky. It needed to be reliable, which meant minimizing the required moving parts. By the 1950s, the U.S. was already at war in Korea, and the Navy and Air Force soon realized that the MiG-15 fighters were outclassing most Allied fighters. They turned to the history books and remembered the Germans had invented air-to-ground missiles during World War II. Then they found McLean and his team. The team had already developed the prototype of their missile after more than 5 years of meticulous studying, with McLean later writing, quote, "I spent nearly 3 years just considering possibilities. It's easy to build something complicated. It's hard to build it so that it's simple." The final design of the AIM-9 Sidewinder missile was indeed simple, yet it turned out to be highly effective as well. It featured a parabolic mirror spinning gyroscopically at an impressive speed of 4,200 revolutions a minute within the transparent nose cone of the missile. This spinning mirror played a crucial role in detecting and tracking the infrared signature of a target. As the missile flew through the air, the parabolic mirror would reflect any infrared blips or heat signatures it encountered. The position of these reflections on the mirror indicated the angle at which the target was located, relative to the missile's axis of spin. The further the reflection from the center, the greater the angle of the missile's flight path. At the heart of the system was a lead sulfide detector. It continuously measured the infrared reflections and generated a current proportional to the heat signal's strength and position. This current controlled electromagnets positioned around the mirror's rim, which adjusted the missile's canard guide fins, small control surfaces on the missile's body. The missile could alter its trajectory by constantly adjusting these fins, effectively steering itself toward the heat source. This ingenious mechanism allowed the Sidewinder to maintain a lock on its target, ensuring accurate mid-flight course corrections and significantly enhancing its hit probability. To prevent interference with the gyro's spin, McLean's team developed rollers, gyro wheels mounted on the tail fin and driven by the airstream, which countered the missile's movements. Additionally, they wired the seeker to aim not at the target's current position, but at where it would be. This allowed the missile to engage enemy aircraft on its own terms, seeking them out, pursuing them, and outmaneuvering them during dogfights. McLean baptized this groundbreaking missile design as the Sidewinder, a poisonous snake that dominated the Mojave Desert close to China Lake. It was a fitting name, but the snake hunts down its prey by sensing its body heat. Future astronaut Wally Schirra, a skilled Korean War veteran with a MiG-15 shootdown behind him, recalled his first visit to McLean's lab. He described the Sidewinder as a dome-shaped device made of glass, which he called a man-made eyeball. He mentioned being a cigarette smoker at that time, and how he noticed the eyeball tracking his movement as he crossed the room. McLean's team ushered in a new age of technological innovation with an object that comprised 14 tubes, less than 24 moving parts, and measured less than 10 feet long and 5 inches across, with a weight of around 160 pounds. The Sidewinder's unique design also pioneered another aspect of military technology. Its onboard guidance system was far more sophisticated than the computers that occupied entire rooms. The missile was, in other words, an almost fully automated robot conceived for destruction. The prototype was tested in 1953, with test pilots left in awe after noticing they could easily lock in not only flying target aircraft, but smaller objects like buses, trailers, and small locomotives around China Lake. In 1956, the Sidewinder was taken to sea for use with carrier aircraft, with U.S. Navy Lieutenant Commodore C.A. Tierney later bragging, quote, "It's like having a 6-foot reach on the other fellow in a boxing bout." 2 years later, the U.S. launched Operation Black Magic, supplying the Republic of China Air Force F-86 Sabres with top-secret ordnance. The enemy was utterly unaware of the Sidewinder. The Communist Chinese and the Soviets were confident in the superiority of their MiG-15s and MiG-17Fs, but soon found out about the hidden ace up the Sabre's sleeve, the heat-seeking Sidewinder. While the enemy was faster and could fly higher, the Chinese pilots were bewildered by the devilish missiles that followed them anywhere, no matter the evasive maneuvers they tried. One after another, they went down in a skirmish, caught by surprise. The airfight was a complete success for the Allied Taiwanese. It proved to the U.S. that the Sidewinder was the next step in the evolution of air warfare, ensuring a series of variants that would make it more lethal and effective for future wars. Decades later, Major Justin Hassard Lee, a U.S. Air Force F-35 pilot instructor, would summarize how the Sidewinder revolutionized air warfare, stating, quote, "We no longer had to get to the perfect place in space and time to allow a bullet to hit another aircraft traveling 500-plus knots, but rather just had to get behind the enemy aircraft generally." While the Soviets were hard at work trying to reverse engineer the Sidewinder and would eventually come up with the Vimpel K-13, the U.S. was already developing advanced variants of the original design. The Sidewinder remains in service almost 70 years after its first launch. However, given its many upgrades, it's virtually unrecognizable from the variant that first flew in the 1950s. Since then, the Sidewinder has seen plenty of combat in several wars, including the Taiwan Strait Crisis, the Vietnam War, the Falklands War, and the Gulf War. Over 110,000 missiles have been produced so far, and the Sidewinder has been verified with more than 270 aircraft kills. The latest shootdowns of a Sidewinder, the highly advanced AIM-9X, were verified in February 2023, when a U.S. Air Force F-22 intercepted a Chinese spy balloon in Surfside Beach, South Carolina, at an altitude of 60,000 feet, and took it down with the legendary Sidewinder, claiming the first balloon missile victory. Today's highly advanced Block II AIM-9X missiles, which entered service in 2015, represent the pinnacle of the Sidewinder's evolution. These cutting-edge missiles can be used over the horizon, enabling pilots to fire without a lock and allowing the missile to acquire its target during flight. Remarkably, they can even attack ground targets like tanks without any modifications. The Sidewinder remains the most widely deployed air-to-air missile in the world, equipping American fighters from the venerable F-15 to the state-of-the-art F-35s. Who could believe this incredible milestone was achieved from an inside program that came out of McLean's hobby shop, and not the top-tier engineers of the arms industry of the Cold War?